All right, guys, let's do it. Whoa, let me switch up here. All right, there we go. All right, welcome in, guys. So this part of your shelf work. So what I'll do is I'll go over how to actually solve this particular shelf work piece. All you're doing is you're taking these pieces here, these states of matter, and you're putting them on this graph. So keep in mind you have temperature on your y-axis, and then you have heat energy on your x-axis. What I'm going to be doing is I'm going to be labeling these for you guys, okay? First line is here, right? So as increase the heat, the temperature goes up, and this first that we're going to use is actually a solid, right? The next state of matter is actually right here, okay? And that's going to be a liquid. Oh, there we go. Next state of matter is going to be a liquid. So you've got something like this. And then as they're catching, you guys should be able to conclude that this last line here, a gas. So what this is saying is, as you increase the heat, you go from a solid to a liquid, and as you increase the heat energy, you go from a liquid to... Now, if you see these here, there's a state between solid and liquid, right? And to go from a solid to a liquid, you need to melt, right? Or you need to be melting here. Now, of course, the last piece that you guys have is the state between a liquid and a gas, which is evaporation. Now, on your work plan, you guys have something that looks exactly like this. It's going to ask you some questions, and hopefully it should help you guys understand where these states of go. Now, what I've done is I have these pictures, these particle drawings, and I want you guys to place over their respective states of matter these changes, right? Something like this. It's that all of the molecules are stuck together, they're vibrating, so they're really closely packed. That resembles a solid. Now, ask yourself, what would melting look like? Is it completely a liquid, or is it still partially a solid? And if you're saying so, if it's partially a solid, then you are correct. And so for that one, I would grab this particular one. So I'm going to go above here. Notice how you have a lot of solids that are clumped together, particles that are clumped together representing solid. But here, you have some particles that are being released, or that are going into liquid phase, right? It's not quite solid and you're not quite liquid, you're a little bit both. And now when you're liquid, the molecules are more spaced, and they allow enough room to kind of slide past one another. So this one here, as you can see, molecules are still closely packed together, but there's enough space they can wiggle through one another. Evaporation, which is this one right here, is a state between liquid and gas. So it's not quite a liquid and it's not quite a gas, a bit of both. So for that one, I choose this giant here. That represents it. So if you notice, you still have a clump of liquids here, and then you have some gases that are starting to escape, and I put arrows to indicate them moving. Last but not least, a gas. It's just a bunch of particles just move randomly spaced out. Perfect. All right. One thing that will help you get out on your work plan is I want you guys to note that when you are increasing heat energy in a solid, you're increasing the temperature. But when you're actually melting, notice that you're increasing the temperature. So the temperature actually stays the same. You are increasing the heat energy, right? And when you get into that liquid phase, oh no, my battery's about to die. That liquid phase, you are increasing the heat, and you're also increasing the temperature as well. Okay, that should help you guys out. And then last note, I want you guys to notice that temperature is the average kinetic energy. So how fast these particles are moving is going to determine how or what the temperature is, right? So a temperature of a solid is going to be much less than the temperature of a liquid, because the molecules in a solid, the kinetic energy between them, the average, is moving much slower. All right, thank you guys.